Hello, welcome to problem 2 of the final review. All right, so for this one, we're going to consider a market with 500 consumers of type A. These type A consumers will have preferences given by this Cobb-Douglas utility function. These consumers will have an income of 20, and then we're going to consider 500 more consumers of type B with preferences given by the minimum of 4x and 3y. So these are perfect complements. And these type B consumers will have income of 10. So what we're going to do first here is we're going to find the aggregate demand for x, given the price of y is 1, and we're going to denote the price of x as p. Okay, so for part A, just find aggregate demand. So find demand for both, or for each type, and just add them. All right, so we're going to find the demand for each type, and then add up how many consumers are of that type, and then just add their demands together. So I'll talk about that more in a bit, but what we're going to do is just going to find demand for part A, or for type A. So we have UA of x and y is equal to x to the 1/3 times y to the 2/3. Okay, so what we're going to do here is we're going to use tangency. So what that means is we're going to set the marginal rate of substitution between x and y equal to p over 1. Again, because px is equal to p, py we're assuming is equal to 1. So what we're going to do is we're going to find the MRS and set it equal to p. MRS is going to be the derivative with respect to x divided by the derivative with respect to y, or the partial derivative. So it's going to be 1/3 x to the negative 2/3 y to the 2/3 divided by 2/3 x to the 1/3 y to the negative 1/3. So what I can do here is I can simplify this. This will become 1/2 times, on the top I'm going to have y, on the bottom I'm going to have x. Okay, so this is the marginal rate of substitution for Cobb-Douglas. Now, I'm going to impose tangency. I'm going to write up here that this is tangency. So I'm going to set 1/2 y over x equal to p. So this means I will have y is equal to 2p times x. So now I'm going to plug this into the budget constraint. Or the budget line, whatever you want to call it. So here we have px plus py, which is just 1, times the amount of y we're going to buy, which again here is going to be 2px. Now this is equal to the income or the budget of consumer A, which is MA, which is equal to 20, I believe. Just gonna check. Yes, 20. Okay. So this means I have 3px is equal to 20. And in other words, this implies that px, or actually x, equal to 20 over 3p. All right. So this gives us the demand for x as a function of p. This is what we want. This is the demand for x for consumer A. All right, now we're going to do a similar thing for B. So their utility is the minimum of 4x and 3y. And they have income of 10. So what we're going to do here, these are perfect complements. So the consumer will set 4x equal to 3y. We're going to plug this in to the budget constraint. So 4x equal to 3y implies y is equal to 4/3 times x. I just rearranged this to solve for y in terms of x. We'll see why this is useful when I plug it into the budget constraint. So plug it into the budget constraint, px plus the price of y, which is 1, times the amount of y I buy, which is 4/3 x. I set this equal to their income, which is 10. So here, I get that x times p plus 4/3 is equal to 10. In other words, x is equal to 10 over p plus 4/3. I could rewrite this I could write this as x is equal to 10 over p plus 4/3 times 3 times 3/4. Yeah, so what I can do is I can just multiply the top and the bottom by 3. So this is 30 over 3p plus 4, just to get it in a way that is consistent with the solutions and a way that is a bit nicer to work with. So I'm going to call this xb. This is the demand of x for consumer B as a function of the price of x. So now So what I'm going to do is I'm going to multiply so it's the number of type A times the demand for type A plus the number of type B times the demand for type B. So this is the aggregate demand. I'm just going to plug in the things that I found up here. So it's going to be, I'm trying to remember, it was like 20 well, okay, number of type A is 500 times 20 over 3p plus 500 times 30 over 3p plus 4. And then what I can do is I can just simplify this. So this is 1,000 or 10,000 over 3p plus what I'll get here is I'll get 15,000 divided by 3p plus 4. So this is the aggregate demand for good X as a function of the price of X. All right, so that's just an application of the tools we found in the first part, where we just find the demand given the utility function, and then we just add up the demands based on the number that we have of each type. Okay, so that's part A. Now what we're going to do is we're going to consider the supply side for part B. So we assume there's this cost function. It's 80q minus 8q squared plus 1/3 q cubed. All right, so there are many firms producing good X. They all have this same cost function. So we want to find the equilibrium quantity, and then we're going to consider like what happens when there is free entry. And finally, we're going to find the market price. Okay, so B. We have C of Q is going to be 80Q minus 8Q squared plus 1/3 Q cubed. Okay, so what we're going to do here is we're going to find the equilibrium in the case of free entry. So to do this, we need to find the efficient scale and then use that to find the minimum average avoidable cost. Why do I say this? Well, it's because P star, the equilibrium price, will equal the minimum average avoidable cost. All right, so we're just going to have that. So that's what we want to find. So the avoidable cost is 80q minus 8q squared plus 1/3 q cubed. I don't believe that we have any fixed costs to keep track of. So the average avoidable cost is equal to 80 minus 8q plus 1/3 q squared. What we want to do is we want to minimize the average avoidable cost. This means we'll take the derivative, set it equal to 0. That would allow us to find the efficient scale. So I'm going to take the derivative. This will be equal to -8 plus 2/3 q. I'm going to set this equal to 0 because I want to find the minimum. So this means 2/3 q is equal to 8. In other words, 2q is equal to 24, which implies that q is equal to 12. All right, so this is the efficient scale. Okay, so now AAC min is just the AAC evaluated at the efficient scale. So I'm going to plug 12 in, and I would get 80 minus 8 times 12 plus 1/3 12 squared. Okay, so just doing a bit of mental math here. This is 80 minus 80 times 10 plus 8 times 2, so that's going to be 96 plus 1/3 times 144. Okay. So I believe this is going to be a negative 16. And then the 144 divided by 3 is going to be, give me a second here, I think 48. No. No, it was 48, I think. Yeah, okay, I second guess myself. Never second guess yourself. Go with your gut. Yeah, 48. Okay, so this becomes 32. So this is the average avoidable cost. So this is the equilibrium price with free entry. Now, all we have to do is we have to find the equilibrium quantity. What we do here is we use the demand function that we find in the first part. Okay. So the demand at price 32, we found it was, I'm just going to copy this because I'm lazy. Work smarter, not harder, as the saying goes. So here, I'm just going to replace all the 3 P's. I'm going to replace them with 32s. Or I'm going to replace the P's with 32s. Okay, so what I'll get here is 10,000 divided by 96 plus 15,000 divided by 96 plus 4, which is just 100. So, good old 10,000 over 96 plus 150. That feels good. This, you could simplify this. This becomes 625 over 6 plus 150. The idea is this is telling us the equilibrium quantity with free entry. All right, so I need to check if that was all that we needed to find. Yeah, so we found the quantity as well as the market price. Okay, so now what we want to do is consider the case where the government is going to impose a tax of $8 per unit sold. So we're going to assume this is levied on the producers of the good, and then we're just going to charge them $8 per unit. We're going to find the equilibrium quantity, then we're going to find the equilibrium price, and then we're going to determine the percentage of the burden that's borne by the buyers. Okay, so for part C, T is equal to 8. What we find here is essentially what's going to happen is when we have free entry in the long run, we're going to see that the quantity supplied is going to be elastic. Like, what we're going to have is that this is passed entirely onto consumers. So why do I say this? Well, firms will only supply when P is equal to 32. They will supply 0 when price is less than 32. So they need to be getting 32. Otherwise, they will not buy anything at all. Okay, so what I'm saying here is they're paying an $8 tax. So they'll only supply when they effectively get 32. They have to pay $8. So that means that the equilibrium price is going to be 40 because they're paying tax of $8. So 40 minus 8 is going to be 32. I'm going to denote this by like PT, the superscript. So to solve for quantity, we do the same thing as we did before. We'll just plug this new price into the quantity demanded. So QD of 40 is going to be 10,000 over 3 times 40 plus 15,000 over 3 times 40 plus 4. So we get a nice 10,000 over 120 plus 15,000 over 124. Simplify your own risk. I think I'm just going to leave it at that. Okay, I'm not feeling super ambitious today. It's late. Now finally, what I'm going to do for part D is we're going to consider the government's revenue raised with the tax and the welfare loss. Okay. And just circling back to the previous question, I talked about this, but I just wanted to make clear the incidence of this here is that the entire burden of the tax is effectively borne by buyers because they pay a price which is $8 more. The producers just charge an $8 higher price. They get the same effective price as they did before. So the only thing that, the tax is actually paid by the buyers. So that's kind of what we find here. Now, finally, just for part D, look at government revenue. So they get $8 per unit sold, and then QT equals 10,000 over 120 plus 15,000 over 124 units are sold. So the revenue is just going to be 8 times 10,000 over 120 plus 15,000 over 124. Okay, just doing some quick maths here, we get this. So 8 divided by 120 is just 1 over 15 plus 15,000 over like 15.5. Not super clean numbers, but this is what we get. So this is the government revenue as the result of the tax. What we want to do is we want to consider the deadweight loss. So the loss in efficiency as a result of the tax policy. So I like drawing this. To me, it helps me understand what things I need to be looking for. So I should use a different color. So here's the price, here's the quantity. The supply curve is originally here. So this is P is equal to 32, and we're going to raise this up by 8 units up to 40. So this is Q supply originally, and this is Q supply with the tax. Okay, so we just shift up the supply by 8, or we shift it up by 8, yeah. Then the demand function, it's going to be, probably going to not draw it super correctly. Let me think, sorry. So this is the demand function. Sorry, I'm kind of thinking through this in real time. Apologize. Okay, so we have, so I think what we can do so this is QD at 32. This is QD at 40. What we're going to do is we're going to look at this shaded region right here. I was a bit thrown because I don't think this demand function is exactly linear, but I think we're just going to go for it. So what I'm going to do is I'm going to look at the area of this triangle right here. So this vertical distance is just the amount of the tax. This is T is equal to 8. The base is going to be the difference between the quantity we had previously and the quantity we have now. And then finally, the area is just going to be those two things multiplied together divided by 2. So it's just the area of this triangle. So the deadweight loss. So it's going to be the base. This is QD 32 minus QD 40 times the height of the triangle, which is just going to be the amount of the tax, or 8, because again, it's this vertical distance right here. And then we're finding the area of a triangle, so we're going to divide by 2. So this is equal to 4 times 625 over 6 plus 150. Minus, everyone's favorite number, 10,000 over 120 minus 15,000 over 124. I'm not gonna simplify this really, but you could plug this into a calculator and get something. This will just give you the deadweight loss. So anyway, the important part is just walking through, okay, here's how we find aggregate demand. The way we did this was we used, for the first consumer, we used the tangency condition, set the MRS equal to the ratio of the prices, and then we got this condition. We used this and plugged it into the budget constraint for the consumer and solved for the demand for X. Then for type B, we recognize that they have perfect complements utility function, so they will optimally set the inputs of the function equal to each other. This gives us a natural relationship between y and x, which we then plug into the budget constraint right here. This allows us to solve for x as a function of p. So now what we've done is we found the demand for each type of consumer. So the aggregate demand is the number of type A times the demand for type A, plus the number of type B times the demand of type B. We add these together and we get this result. On the firm side, we're going to consider an equilibrium with free entry. So what that means is we're going to find the average avoidable cost at its lowest point. Why do we do this? It's because in an equilibrium with free entry, the price will be equal to this average avoidable cost, like the minimum average avoidable cost. So to do that, we find the formula for the average avoidable cost, take the derivative, set it equal to 0. This gives us the quantity which minimizes the average avoidable cost. So plug that in, find that the minimum average avoidable cost is 32. So this means that the equilibrium price is 32. Now, to find the quantity, plug this price into the demand function. This gives us a nice number for the equilibrium quantity under free entry. All right, so now we're going to compare this to what happens when we implement a tax. So in the third part, we assume there's a tax. Here, firms will only supply when the price that they receive is 32. They'll supply nothing when price is less than 32. So since they have to pay $8, they're going to charge 40, so that at the end of the day, they end up getting 32 per unit. This is the price at which they'll supply. So we find that they just raise prices by $8, plug this into the demand, and then solve for the resulting quantity. All right, so this is what we get. It's not a particularly simple number, but it works. Now for the last part, to find the government revenue, we assume the government gets $8 per unit sold, so that we can find the quantity sold in the previous part. And then the revenue is just going to be the amount of the tax times the quantity that is taxed. So it gives us this number. And finally, to find the deadweight loss, we want to look at the difference in consumer surplus before and after the change. So the amount of deadweight loss is going to be the area of this triangle right here. So we can find the change in demand, find the change in price, multiply them together. Then we divide by 2 because we're finding the area of a triangle. This gives us this number, and we are finished with this problem. Thanks for following along. Hope you have a great time studying, and just let me know if you have any questions. All right, take care.